In this video, I'm going to go over question 3 from exercise 7.3. So let's write out our left-hand side. 1 plus tan squared x over 1 minus tan squared x. First thing I'm going to do is change these tans into sines and coses. So remember, you are not given that tan is equal to sine over cos. That's something that you will need to remember. Okay, there is another one you need to remember as well. So just check on your identities. Let's move that up. Right, so here I have two terms on the numerator, two terms on the denominator, and I need to make them one term, one combined term. So I'm going to transform this 1 into a fraction with cos squared x on the bottom. Now remember, 1 is already a fraction. It's 1 over 1. Okay, so now I need to have it so that the denominator of this fraction is the same as the denominator of this one. So if I multiply top and bottom by cos squared x, then they will have the same denominators. So let's do that. Okay, so I'm changing pen. So cos squared x over cos squared x plus sine squared x over cos squared x. And if I shift that up, so that's the top. The bottom is the same, isn't it? Except for that we're going to have a subtraction between the two terms. Sine squared x. So now I have common denominators. I can then make that a single denominator. So on the top I'm going to have cos squared x plus sine squared x all over cos squared x. The bottom is cos squared x minus sine squared x all over cos squared x. Whew, hard work here. Let's have a look at this. Well, I've got a fraction divided by a fraction. Well, if you're dividing fractions, you flip the second fraction and multiply. So let's write it out like that. So I'm going to take my first fraction, doesn't change. I'm no longer dividing, I'm now multiplying. And the second fraction flips over. Okay. Now let's look at each of these parts. So we've got cos squared x plus sine squared x. Well, that's your other national 5 identity. That equals 1. Okay, so again, that's something you're going to need to know. Let's look on the second side here. Well, I've got cos squared x on the top. Now on the bottom, we've got cos squared x minus sine squared x. Now that is the little used compound double angle formula for cos 2x. So cos squared x minus sine squared x is cos 2x. Now I know in the work solutions this looks a bit like cos squared x on the bottom there, but it is actually cos 2x, which we're going to need, aren't we? Because that's what we need to have it equal to here. Okay, so let's go all the way back down here. What have I got left to do? Well, I've got a cos squared x in a numerator and denominator, so they can cancel, leave me 1 and 1. And all I'm going to be left with is 1 times 1 in the numerator, 1 times cos 2x, so cos 2x. And if you look right back at the start, that is what we were hoping for. So I've proved my identity.